Welcome to the Behaving Brain, the channel where we explore the fascinating world of the brain and how it shapes who we are. If you're new here, make sure to like and subscribe and click the bell button for notifications. For centuries, the concept of reincarnation has captivated the human imagination. Across cultures and throughout history, people have pondered the possibility of souls being reborn into new bodies. Each life is a new chapter. Each life builds upon the experiences of the past. It's a captivating idea full of mystery and intrigue. But what does science have to say about this age-old belief? In the realm of neuroscience, we explore the very essence of what makes us who we are, our brains. The brain is a complex organ. It is responsible for our thoughts, emotions, memories, and that unique sense of self. But can this self, this essence of who we are, somehow transcend the physical confines of our brains and find a new home after death? This is a question that has no easy answers. It delves into the very nature of consciousness, the soul, and the relationship between the mind and the brain. While we may not have definitive proof, exploring this possibility through the lens of neuroscience can offer intriguing insights into the nature of self and the mysteries that lie beyond. Now let's begin. To even begin to approach the question of reincarnation, we need to understand where our sense of self comes from in the first place. Neuroscience points to a network of brain regions that collectively give rise to our conscious experience and our feeling of being a unique individual. One crucial player in this network is the default mode network, or DMN. This network hums with activity when we're not focused on the outside world. It's active when we're daydreaming, reminiscing, or contemplating our own thoughts and feelings. The DMN helps us construct our personal narratives. It's the inner storyteller of our lives. Another key region is the anterior cingulate cortex, or ACC. The ACC sits deep within the brain. It acts as a kind of error detection system, constantly monitoring our actions and experiences for anything unusual or unexpected. This helps us learn from our mistakes and adjust our behavior accordingly. And then there's the insula, a brain region tucked away deep within the folds of the cortex. The insula plays a vital role in our subjective emotional experiences. It helps us feel the full spectrum of human emotions, from joy and love to sadness and fear. Together, these brain regions and others work in concert to create our sense of self. They weave together our memories, emotions, and experiences into a cohesive narrative that defines who we are. But what happens to this intricate tapestry of self when the brain that created it ceases to exist? Imagine for a moment that we could somehow transfer the entire neural network responsible for our sense of self, all the memories, emotions, and experiences encoded within, into another brain. Would that person then become us? Would they inherit our personality, our quirks, our deepest fears and desires? This thought experiment highlights the profound mystery at the heart of reincarnation. If our sense of self is entirely a product of our brains, then it stands to reason that it should be transferable, at least in theory. But the reality is far more complicated. Our brains are not static entities. They are constantly changing and adapting in response to our experiences. Every interaction, every book we read, every conversation we have leaves its mark on the physical structure of our brains. This process is known as neuroplasticity, and it's what allows us to learn, grow, and adapt throughout our lives. Think of the brain as a vast, ever-changing landscape. Experiences carve out valleys and raise mountains, diverting the flow of neural activity and shaping the terrain of our minds. This dynamic interplay between our experiences and our brains means that our sense of self is not fixed or immutable. It is constantly evolving, shaped by the countless events and interactions that make up a lifetime. If we were to transplant our neural network into another brain, we would be transplanting it into a different landscape, sculpted by a different set of experiences. The result would be a fusion of sorts, a blending of two distinct histories. The recipient brain's own unique wiring and plasticity would inevitably interact with the transplanted neural network, creating something altogether new. It wouldn't be an exact replica of the original self. Instead, it would be a hybrid, a unique entity shaped by the convergence of two distinct life stories. Perhaps we catch glimpses of this blending of experiences in the strange phenomenon of déjà vu. That eerie feeling of having been somewhere before, even though we know we haven't, might be a fleeting echo of a past experience, a neural pathway briefly activated in the vast network of our brains. Or consider the feeling of familiarity we sometimes experience with strangers, as if we've met them before. Could this be a subtle manifestation of shared neural patterns, a resonance between two minds that have traveled along similar experiential paths? These examples, while speculative, hint at the possibility that our sense of self is not confined to the boundaries of our individual brains in the way we might assume. Perhaps there are subtle yet to be understood connections between minds, echoes of experiences that transcend the boundaries of time and space. The question of whether reincarnation is possible from a neuroscience perspective remains firmly in the realm of speculation. We simply do not have the tools or the understanding to study such a concept empirically. However, pondering this question forces us to confront the profound mysteries of consciousness, the nature of self, and the relationship between the mind and the brain. While we may never know for certain whether reincarnation is possible, exploring the idea through the lens of neuroscience can deepen our appreciation for the complexities of the human brain and the boundless mysteries of the universe we inhabit. And who knows, perhaps someday science will unlock the secrets of consciousness and reveal the true nature of the soul's journey. Thanks for watching. Check out how a tumor pressing on the amygdala can make you a murderer in the case of Charles Whitman, or gain a deeper understanding of the mechanism of addiction through the reward system. Like and subscribe so you don't miss the next video on the behaving brain.